Hi again, my name is Gene and welcome to the second drone coding video from CAPS Drone Academy, located in CAPS Charter School, which you can find in Paterson, New Jersey, or in 12 other locations. This video is unofficial, which means it is not approved by the school officially, but I hope you find it useful. Oh, and I don't want to mislead you in any way. CAPS is a public, tuition-free charter school. Its goal is to unlock the college potential in as many students as possible. Okay, let's get back into drone coding. And today we're going to be programming these drones to become autonomous agents. Now, what is an autonomous agent? It's a robot without a joystick. It's a robot that can use its sensors, for example a camera, to perceive its environment, for example detect faces, and to make decisions, for example turn right, go forward, and act on those decisions, which means to actually do this. Uh-oh. If your high school or middle school already has a team that competes in first robotics competition every year, then you probably already know what autonomous agents are.
To take the revenge match in match number 1, Newton looking to equalize here, starting off the scoring. Daly looking at a strong start, but Newton coming back in the final second of autonomous control. Daly and Newton tied at 41. Drivers take control.
In first robotics competition, the first 15 seconds of the game are completely autonomous, which means students have programmed their robots to drive and score completely on their own. Nobody is allowed to touch their joysticks. Very often, the team who scored the best in the autonomous part of the game wins the whole game. Same as the case with Bell Helicopter Advanced Vertical Robotics competition, where the students must program their drones, design their drones, and very often the team who has the best autonomous program ends up winning the whole competition. If you haven't watched the first drone coding video in this playlist about situational awareness drone, please watch it first, because it will take you through all of the installations that we need to do in order to make this one work. The link to that video is the first link in the description. If you watched that video before, you probably already downloaded the code for CAPS Drone Academy into your PyCharm. If you have not done this, so I'm just gonna do it once again. I'm opening my PyCharm. I'm clicking Get from VCS, and I'm going to put the link for the CAPS Drone Academy code, and hit clone, which means download. If I click in the upper left corner, I'm supposed to see the CAPS Drone Academy code files in here. And today we're going to be working with this one, watchdog drone. But before it can work, we need to click on the lower right corner and create an environment with the version of Python that we want to use. I'm going to be using Python 3.9. And I'm creating a new virtual environment. Clicking new in here. Okay. It is getting created. And the next thing that we need to do is we need to install the requirements. We have a button here to install requirements. If you don't see it, you can just go to this requirements file on the left, and everything is highlighted in yellow, which means it's not installed. We can hit install all missing packages in here. If you're on Chromebook, this will take forever, but it will finish, don't worry. Something has not installing. Let's see. Can we troubleshoot this? Maybe I'm not connected to Wi-Fi? No, I'm connected to Wi-Fi. So, but still, what do you do if you experience trouble installing packages like this? What you do is you can click. Let me just drag this window a little to the side. In here, you can click on this button, Terminal, to open a new terminal, which is this black window with command line interface. And what you do into it is you can install things manually by typing pip space install -r requirements.txt, which is your manually commanding asking to install everything that's in this file, requirements.txt. Enter. And things are getting downloaded from internet and they are getting installed. Now there is nothing yellow highlighted in this file. Everything is installed successfully. Now, if you watched the first video in this playlist, you have it all installed and done already. Now let's actually get to what we're going to be doing today. The code for the object detection autonomous drone is located in watchdog.drone.py here on the left. You can click the project button in the upper left corner of your screen and then navigate to the watchdog.drone.py code. If you don't see it, go here to the file menu, you can close project and then open it again and you will probably see it. Sometimes it happens in PyCharm. Let's read the code for the watchdog.drone.py. First, there is an import section in which we say we're going to be using these packages of code that somebody else wrote. Then we're creating two detectors for detecting objects on the video. A face detector, which you already saw, and a tag detector. Tag detector is for detecting things called April tags. An April tag is a visual marker like this one. It's very easy for a robot to see, even easier than a QR code. The second link in the description of this video is a link that you can click to print out some of those April tags for yourself, because it will be very easy for your drone to see them. Let's get back to the code now of this watchdog.drone.py. The next lines of code connect to the drone, and then the while loop starts, which you remember from your practice in Code Combat or any other coding game. While loop is the loop that takes forever, doing the same thing over and over. First, the drone is going to check if you pressed any key, and if the key is T, which is takeoff, drone.takeoff function is called, so drone will perform a takeoff. Whether or not this happened, the next thing that will take place is a frame of video will be taken from the drone camera. And then our detector, for example, a face detector or an April tag detector, will detect, is there anything interesting on that frame of video? Is there a face, for example, like we saw in the face detection example? And the results of this detection will be the location of that face, X and Y, as well as the size. Is it big? Is it small? Width and height. We're going to display it right on the video, but we're going to display the normalized X and normalized Y, just like in school coordinate plane. If X is negative, the object is on the left, and if X is positive, normalized X, the object is on the right. If Y is positive, the object is above. If Y is negative, the object is below. Let's see how it works with my face. Okay, time to start our drone. I'm going to put the battery into it, like this. Then I'm going to put the button in here to turn it on. I don't know if you guys can see it well. Giving it a long push. And the light on the drone should start blinking pretty soon, which means I can connect to it over Wi-Fi. I'm pulling up the list of my Wi-Fi networks. I see Tello, and I'm already connected to the Tello drone network. Tello is this drone in here. Then I'm going to go to my PyCharm. I'm going to say current file, and I'm going to hit run. I'm going to run this program. And the drone video will soon come up, as you will see. On the Chromebook, you will have to wait for a little longer, but it will be here. Okay. So the drone is detecting my face. Let's take a look at the value of X. Because my face is right in the center of the frame, X is near 0. If my face will be on the right, X becomes positive, plus 20, plus 30. It's a little dark here. If my face is on the left, the X is negative, minus 30. If my face is at the top of the screen, the Y is positive, plus 20. If my face is on the bottom of the screen, the Y is negative, minus 26. Now, if it is straight in the center, both X and Y are almost 0, minus 1, plus 4, something like this. I'm gonna stop the program. Going to go back to PyCharm and hit the stop button. Okay, the program is started. The drone video is here. And today we have Daniel with us, our youngest student. He will be helping us. I'm hitting the T button on my keyboard and the drone will take off. Well, let's see Daniel. Yes, drone found Daniel. Daniel, why don't you walk towards the wall? Slowly, slowly, slowly. No, you gotta go back into the video. Yes. And now, walk slowly, slowly, slowly. The drone is looking at you. Walk slowly towards the left, towards the left, towards the left. And the drone is turning. Slowly, slowly, slowly walk towards the left. That's right. And the drone, when it sees that you're on the left, it's turning. It's turning towards the left because it's detecting your face. I'm gonna hit the L button. Thank you, Daniel. Oh, why don't you walk to the right? Yeah. Will it find you again? It's turning until it found you. Can you walk to the left slowly again so the drone can see you and turn towards you? Yeah, you can walk. Walk, 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 walk. The drone is turning towards Daniel. Perfect. I'm gonna hit the L button to land. Okay, what can we do for this drone to actually turn right and go up and down if the object is above or below, or if a right turn is needed? Let's scroll down to the code to exercise 1. Can you think of a way to turn the drone right when the object is too far to the right? Too far to the right, meaning that nx is greater than 15. Yeah, I think I know what I need to do. I need to say if nx is greater than 15, which is the object is too far to the right, I'm going to set turn velocity to be plus 40, turn right. Exercise number 2. Can you think of a way to fly the drone up when the object is too far above, which is and y greater than 40, y greater than 40. Okay, if y is greater than 20, then we're gonna set the up-down velocity to be positive. Fly up. For example, with the speed of plus 40 also. Finally, can you think of a way for the drone to fly down when the object is too far below? Y is less than 15. Okay. If and y is less than 15, minus 15, then I'm going to set the up-down velocity to be minus 40. Fly down when the object is too far down. And finally, the last and the coolest. Can you think of a way to fly the drone forward with forward velocity 70? When the object is right in front of us. What does it mean that it's right in front of us? It's not too far to the left, not too far to the right, not too far above, and not too far below. So means it's probably kind of right in front of us. Okay, so if all of that is true, if the object is right in front of us, then I'm going to say forward velocity equals 70. And Daniel is busy playing right now, so he cannot, he's a little too busy to help us with the tests. Daniel, to be clear, is not our youngest student yet. He is my son. He is 4 years old, but he loves drones anyway. He's just busy playing with something else right now. So what I'm going to do is I'm going to put the battery back into the drone, turn the power on the drone on, make sure the light is blinking, the green light is blinking. After this, I'm going to connect to the drone network over here in the list of my Wi-Fi networks. Connect. Put it on the floor. And start this program to see if the drone can detect and chase objects. Oh, but before we start this, instead of chasing and detecting Daniel, which was done on this line of code, detect biggest face, let's be chasing and detecting April tags, which are these things that we discussed, because Daniel is busy playing right now. Now I'm going to hit the start button. What I have done is I have put a pound in front of the line that was for detecting biggest faces. It means I disabled that line, it's commented out. And I have removed the pound that was in front of this line, detect biggest. Now that code will run. Okay, now I'm gonna start. And we're connected to the drone. We're seeing the video of Daniel playing. I'm going to hit the T button for drone to take off. And let's see. This is me, the April tag is detected, and the drone is flying towards it. Hey, here's the tag. It's flying towards the tag, barely missed it. Found the tag again, and it's following me. It's following the tag into the hallway. It is chasing me, I have to tell you. Now it lost me again because I was able to move out of the way. It's turning to find the tag again, and it found it, and it's following me again. It's following the tag. I missed it. I jumped out of the way. Anyway, that's the idea. I'm gonna hit the L button before it starts chasing me again. Oh no. Alright, so today we wrote the code for the drone to become an autonomous agent. It was using its video camera sensor to sense the environment around it. It was using simple AI models to make sense out of it, to detect objects on the video. It was making its own decisions using if statements in here. If the object is on the right, do this. If the object is above, do that. And if it's in front, just chase. And it was putting those decisions to practice. It was acting on them. It was an autonomous agent. Thank you for watching this video with us today. If you have not tried the exercises in the code just like we did, go ahead, scroll back and try those exercises. Should be fun. And see you in the next video.
And see you in the next one with a slightly bigger robot.